Today we are going to be doing lesson 92, uniform motion problems about equal distance. So we saw these equations in lesson 79, but now we are going to put word problems behind them. So if we have the rate of F times the time of F is equal to the rate of E times the time of E. And then I can say, oh, well, the time of F is 16, the time of E is 12, and within the problem it would say something about the rate of E is equal to the rate of F plus 15. So we can have all of these. We would use substitution and elimination. This is basically when you have a distance 1 and a distance 2 that are equal, going the same direction, or also you could have one where the distance 1 and the distance 2 are the same, but they're going in opposite directions. So like if you go to school and then you go from school to home, those are the same distance, just in different directions. That's what that second equation would look like. Okay, so let's look at these as some examples. Example number 1 says, on Tuesday, the express train made the trip in 12 hours. On Wednesday, the freight train made the same trip in 16 hours. Find the rate of each train as the rate of the freight train was 15 kilometers per hour less than the rate of the express train. So this is something I know, that the distance of the express train was the same as the distance of the freight train. So the distance of the express is equal to the distance of the freight. Okay, so my distance equation is going to look something like this. The distance of E is equal to the rate of E times the time of E. And the distance of F is the same as the rate of F times the time of F. So therefore, the distance of E is equal to the distance of F. They're equal, so this is the type of equation that I'm going to use. I'm going to use the rate of E times the time of E is equal to the rate of F times the time of F. Okay, in this problem, it is telling me that the rate of the freight train was 15 kilometers per hour less than the one of the express train. So I can write that as this. The rate of E is equal to the rate of F plus 15. Then I also know that the express train made the trip in 12 hours and the freight train made it in 16. So I know that the time of E is equal to 12 and the time of F is equal to 16. So now that I know all of these, I can just use substitution. So I am going to use this equation right here. RE times TE equals RF times TF. So using all of this, I'm going to plug in some numbers. All right, so RE I know equals RF plus 15. And then that is going to be multiplied by TE, which is 12. And that is equal to RF times TF, which is 16. Okay, so now I'm just going to distribute. I get 12 RF plus 180 is equal to 16 RF. I'm going to subtract 12 RF, so I can move that to the other side, and I get 180 is equal to 4 RF. Divide both sides by 4, and I get that RF is equal to 45 kilometers per hour. If that one is 45 miles or kilometers per hour, I'm just going to stick that back in the equation and add 15. So 45 plus 15, and I get that the rate of the rate of E is equal to 60 kilometers per hour. Example number 2. The members of the girls' club hiked to Lake Tenkiller at 2 miles per hour. Mr. Alley gave them a ride back home at 12 miles per hour. Find their hiking time if it was 5 hours longer than their riding time. How far was it to their Lake Tenkiller? Okay, so we know that they're going to the lake by hiking, so that's the distance of h. And then they were coming back and they were riding in a car, so that would be dr. Okay, so in this, we know that the distance of h is equal to the distance of r. So therefore, we're going to use the rate of h times the time of h is equal to the rate of r times the time of r. We also know that the rate that they were hiking was 2 miles per hour, and the rate of riding was 12 miles an hour. And then it said that it was 5 hours longer, so their time hiking would have been the time of riding plus 5, because it was 5 hours longer. All right, now we're just going to substitute all of this in. So we have 2 times tr plus 5 is equal to 12 tr. So now we're going to distribute. 2tr plus 10 is equal to 12tr. I'm going to subtract 2 from both sides, and I get 10 is equal to 10tr. Divide by 10, and we get that tr is equal to 1. So I know that the time of riding was 1, and then I have the time of hiking would be 1 plus 5, which time of hiking is 6. Now it wants to know, that's how long it took. That's the time, right? Well, now it wants to know how far it was. So we're going to need to do a little bit more to this. The distance is either going to be 2 times 6, which is 12, or you could also say 1 times 12, which is 12, because it took them 6 hours to travel 2 miles, and it took them 1 hour to travel, took them 6 hours to travel at 2 miles an hour, or 12 miles, and it took them 1 hour when they were going 12 miles an hour. So either way, the distance is 12 miles to get to the lake. Okay, Durant drove to the oasis in 2 hours, and Medill walked to the oasis in 10 hours. How far is it to the oasis if Durant drove 16 miles per hour faster than Medill walked? So this is going to be the same distance that Durant drove, so the distance that he drove is the same as the distance that was walked. So since dd is equal to dw, we also know that the rate of d times the time of d is equal to the rate of w times the time of w. We also know that the time of d is 2 and the time of w is 10. The rate of d is equal to the rate of w plus 16. These are all the pieces that we know from the problem itself. So now we're just going to substitute all of this in. So then we would have rw plus 16 times 2 is equal to rw times 10. We're going to distribute that 2rw plus 32 equals 10rw. We are going to move this 2rw to the other side, so we're going to subtract. Then we get 32 is equal to 8rw, divide by 8, and we get that rw is equal to 4. So if rw is equal to 4, then we will say 4 plus 16 is 20. So our rd is equal to 20. And if our td is 20, if our time is 2, then we're just going to multiply 2 times 20 to figure out how far this would have been. 2 times 20 is 40, and that's 40 miles. And since they are equal, it'd be 40 miles driving, 40 miles walking. Doesn't matter which one. Both of them are 40.